Hi everyone, myself Arun Raja, working here in the Department of Aeronautical Engineering as an assistant professor from 2013. In this video, we are going to see about CAM and its classification. First, we have to know what is CAM. A cam is a rotating machine element which gives the reciprocating or an oscillating motion to another element which is known as to be the follower. Okay, the cam is this which rotates and it translates the motion to the next object, which is converted this oscillation motion into a reciprocating motion. That is the purpose of the cam. The cam is operated by n number of machines. One of that is the cam operated valve in 2-stroke and 4-stroke engines. In that engine, this valve is operated by means of cam. This is the schematic representation of that cam operated valve. Once the cam is rotated, the tappet which is connected to the cam is moving in the reciprocating direction, and it just moves the push-pull rod that translates the linear motion for the rocker shaft. With the help of this pivot joint, this rocker arm moves the spring that opens and closes the inlet and outlet valves. According to the type of shape that a cam is, the types of cam based on the type are radial or disc cam, cylindrical cam, translation or wedge cam, conjugate, globoidal and spherical cams. These are the cams which are classified based on the shape. Radial or disc cam. The pictorial representation will give you the working of these radial cams. The follower reciprocates in a direction perpendicular to the cam axis. That is what these radial cams are meant to be. The next is cylindrical cam. In the cylindrical cam, the follower reciprocates or oscillates in a direction which is parallel to the cam axis. In this cylindrical cam, these follower as well as the cam are rotating in the same axis, but the reciprocation movement of the follower also happen in the same direction. The next is translation or wedge cam and conjugate cam. In the wedge cam, it has a translatory motion and the profile of the cam is formed on the one side of the cam. The next is conjugate cam. By the picture itself, we can understand that the conjugate cam has two discs keyed together and having a contact with two different rollers of followers. We will see the type of followers later in the video. The next is globoidal and spherical cam. The globoidal cam have concave or else convex type of surface that will cut on the circumference of the cam, which impart motion to the follower to oscillate the fulcrum, which is about the fulcrum. Okay. In case of spherical cam, the form of spherical shape which transmits the motion to the follower to oscillate in an axis which is perpendicular to the rotation of cam. Likewise, the type of cams, there are types of followers too. According to the follower movement, the motions of the followers distinguished from each other by means of dwell they have. A dwell is a zero displacement or absence of motion, or the follower as rest during the motion of cam. Cams should be classified according to the motion of the followers in the way of DRD cam, that is dwell, rise, dwell, return and dwell. And the next is dwell, rise, return, dwell, DRRD cam, rise, return, rise, triple R cam, and Dwell rise dwell DRD cam. These are the displacement diagrams for the cams which considered to be different follower motions. Here you can see this dwell rise and dwell return, and the complete rotation will stops at 360 degree. From 0 to a certain degree, the cam will have some dwell. After attaining the particular value, it will rise to the maximum value, that is their displacement, and it will hold at the point for a few moments, and it will return to the starting position by the next rotation. In this next step called dwell rise return dwell, here one of the dwell is not considered here, so initially it's part of dwell, then the rise is happened for part of rotation. After immediate reaching the maximum displacement time or distance, it will return back to the dwell position for the remaining rotation. The next is RRR cam. In this RRR, the total 360 degree will be considered to three different conditions: rise, return and rise again. The total 360 degree is having rise return. There is no dwell in this process, but in the case of fourth condition, dwell rise dwell DRD, then this type of motion, initially there will be a dwell, and by taking a part of rotation, it will rise to the maximum displacement value and it sustains at the maximum displacement for the next rest of its period. According to the manner of constraint of the follower, we can classify the cam also. The cam can be classified according to the actions. Preloaded spring cam. A preloaded compression spring is used in this type for the purpose of keeping the contact between the cam and follower. There are two types of contact: surface contact and point of contact. The positive drive cam, in this there should be a constant touch between the cam and the follower, and it is maintained by a roller follower which is placed in a groove of a cam. The follower cannot go out of its groove under normal working operations, but in higher rotating speeds it may go out. A constraint or positive drive is also obtained by use of this conjugate cam. The next is gravity cam. The rise and return of the cam is done by the gravitational force acting on the cam itself. However, these cams are not preferred due to their uncertain behavior due to the force acting on the cam. In the case of preloaded spring, the spring is used to make the contact between the cam and follower. There will be an external force acting on the cam to make the contact successful. In case of positive drive cam, there is no need of those external forces to generate the contact between the cam and follower. The types of followers, according to the surface in contact between the follower and cam: radial follower and offset follower. And also there will be a surface in contact between those two major rotating machines: knife edge follower, roller, flat faced, spherical faced followers. According to the motion of the follower, we will classify the follower into translatory motion follower and oscillating follower. The radial follower is the motion of the follower along the axis which is passing through the center of the cam axis. The above figure will give the explanation about these radial followers, which we can see that the axis of the cam and axis of the follower are in same axis. But in case of offset follower, the axis of the follower is slightly moved away or offset from the cam axis. Then knife edge follower, in this type, the followers are having a point of contact that will generate a sliding motion to the follower. But in the case of roller follower, the sliding motion of the knife edge is replaced by rolling a small roller over the cam. The biggest advantage of these roller followers is the rotation of the follower at high speeds. The next is flat face follower. In this type, the follower used in preference to the roller follower will be space limited. In this case, there will be a constraint like the distance between the cam and follower is to be very minimum. The next is spherical face follower. In this type of follower, to minimize the surface stresses generated in between the cam and follower, the flattened follower is machined to a spherical shape. Then it is called by its name as spherical faced follower. Types of motion: translatory motion follower. In this follower, the translatory motion is generated by the rotational motion of the cam. In case of oscillatory motion, the same rotational motion of the cam is give a oscillating motion to the follower. That's it for the classification of cam and its follower. Thank you.